was not nice.
My grandma's me with her hearing aids on. I can't.
Oh my gosh. All right, what are the zeros? Right there. We're going to do the inverse. We're going to verify. We're going to graph a power function. We're going to do polynomial functions, sketch it. We're going to factor. We're going to long division and synthetic division. But done. Done. I know, about. I have it. It's too long. I have to take some off. Okay, so these are our zeros. So next, what's the next thing I need? Well, all right, here's the graph. Okay, I need the degrees. What is the degrees, Jordan? That's not the degree. That's still not the degree. Thank you. 5. And the leading coefficient is positive, which makes my end behavior. Okay, down and up. What's the next thing I need? I have the zeros. I need the y-intercept. So what is the y-intercept? Negative 108. So negative 108. So I know I'm going through that point right there. And I have negative 2, and I have positive 3. So the question, I had several as I walked around. If the end behavior is down, but I get a bounce here, where's the bounce? Top or bottom? It has to be on the bottom because this goes down. Okay, and notice that I have an arrow on the end, and it's a nice smooth curve. It's not pointy, and it's, I don't know, it doesn't have a bunch of crap in it, okay? So then, what happens at 3? I get a point of inflection, and it doesn't float in the air. It happens at 3. So I'm going up, change direction, and up. So this is what your graph should look like, about. And everybody should be able to do these. Okay, on your notes. So yesterday we talked about long division, and today we're going to talk about synthetic division. We like synthetic division because it's faster and it's easier. When do you have to use long division, though? When there's an x squared, when there's an exponent, when's the other time? What about the leading coefficient? Yeah, if it's not 1, you have to use long division. So if you look at all these examples, the leading coefficient on the factor is 1. So all these work with synthetic division. Okay, so I'm going to start with number 13. So when we do synthetic division, we write down all of the coefficients. So I have 3, negative 22, 37, and negative 10. So yesterday when we did long division, we divided by the factor. With synthetic division, we're testing a 0. So I'm given the linear factor, so what do I divide by? Well, negative 2 is in the linear factor. What's the 0? We have to divide by positive 2. So this is how it works. I'm going to bring down the 3. 2 times 3 is 6. I'm going to add. Gives me negative 16. 2 times negative 16 is negative 32. I'm going to add. It's 5. 2 times 5 is 10. That's 0, and that's your remainder. And the way you write the answer, whatever you start with, and this is a 3, you go down 1 degree because I divided out the x. So this started at the third power, so I'm going to start at the second. 3x to the second minus 16x plus 5. What? So let's do the next one. I'm going to have 4, negative 16, 20, negative 16. And what do I divide by? 3, and start with the 4. Go. Did everybody get this for the synthetic part? So this time we have a remainder, which is okay. So I started with 3, so I have 4x squared minus 4x plus 8 over this. So on problem number 17, the only thing that changes is like yesterday, when we're missing factors, you have to fill in zeros. So here, what am I missing? I have a fourth, a third, I'm missing a squared, and I'm missing the x, right? So when I write this down, I'm going to have 1, negative 9. I have 0x squared, I have 0 x's, and then a minus 1. And I'm testing the factor of 9. I'm going to start by bringing the 1 down. 1 times 9 is 9. When I add, I get a 0. And then all of you are going to stop because you get a 0. You're like, oh, what do I do? Well, what's 0 times 9? 0. When you add 0 plus 0, what do you get? Okay, and now all of you are like, wait, I did something wrong. I have 2 zeros in a row. No, just keep going. 9 times 0 is 0. I'm going to add. I got 0. 9 times 0 is 0. So I get negative 1 out at the end. So I started with x to the 4th. So what's 1 less? X to the 3rd plus a negative 1 over x minus 3. It's okay. It's all right if it looks weird. X cubed plus negative 1 over x minus 3. Okay. So this is what we use. This is why we do this. This is why we do long division and synthetic division. If I start with this polynomial right here, and I want to test this factor, x minus 4. So first of all, what I'm going to do is we're going to do synthetic division because of the leading coefficient of 1. So I have 1, negative 5, 2, and 8. And I'm testing 4. So when I do that, I get 4. So once I divide out the x minus 4, now my f of x is this. Right? I started with x to the 3rd, so this is x squared minus x minus 2. So if I look at this, does this factor? It does. A times c is negative 2, my b is negative 1. So that's going to be negative 2 and 1. So my function becomes x minus 4 times x minus 2 times x plus 1. So the zeros of my polynomial are 4, 2, and negative 1. So I want to do the same thing here. So I'm going to divide out the negative 3 and see if what's left over factors. So I'm going to have 2, negative 3, negative 32. So once you do the synthetic division, this is what you should get. How many got this far? Yes? So then you have to check it and see if it factors. So my A times C is negative 10 and my B is negative 9. So does that factor? So negative 10 and 1. And I have a leading coefficient. And what happens with the 2x minus 10? Yep. So you get x plus 3 times x minus 5. So I can get my zeros, negative 3, 5, and negative 1/2. Where did it go? You can reduce that factor. So I think we could all agree this is a lot of writing, right? But there is not one hard thing we are doing, not a single hard thing. It's just a ton of writing. Okay, last problem. We're going to do 21 because it just looks a little different when we're done. Okay, so I'm going to test positive 1. I'm going to start with 2, 1, negative 11, negative 4, and 12. So I have a 4th degree polynomial, and I'm going to take out x minus 1. I'm just going to see what's left over. So when I do that, I get no remainder, so it's probably going to factor. That's my hint that it's probably going to factor. So my function is now x minus 1, and this started at x to the 4th, so where do I start my new polynomial? Okay, 2x to the 3rd plus 3x squared minus 8x minus 12. So how do we factor if there's 4 terms? Right. Very good. So we're going to factor by grouping, okay? So if I do factor by grouping, the first 2, China said we're taking out x squared, I think, right? Okay, so if I take out x squared here, I'm going to have x squared, and I'm going to have 2x plus 3. And what do I take out of the second set? Negative 4. So if I take out negative 4, I get 2x plus 3. So here's my function. I have x minus 1. I have 2x plus 3. And then I have x squared minus 4. And what happens with the x squared minus 4? One more time. So my zeros are negative 1, negative 3/2, and then plus and minus 2.